Let us do one more problem based on pH calculation of weak acid. Calculate the pH of 0.1 and CH3COOH solution. This is an acetic acid solution. We all know that acetic acid is a weak acid. The weak acid undergoes feeble ionization. It undergoes a partial ionization in aqueous solution as follows: CH3COOH. It undergoes a partial ionization to form a very few number of CH3COO minus ions and H plus ions. If alpha is the degree of dissociation and C is the concentration of the weak acid, in case of the theory of dilute solutions, Ostwald's dilution law, while discussing about Ostwald's dilution law, we have studied if at equilibrium the concentration of acetic acid is C into 1 minus alpha, where alpha is the degree of dissociation of acetic acid, and the concentration of acetate ions at equilibrium is C into alpha, and the concentration of H plus ions at equilibrium is C into alpha. So the concentration of H plus ions is equal to C into alpha, but we have shown that alpha is equal to C into, the value of alpha is root of Ka divided by C, where Ka is the dissociation constant of acetic acid. Here the value of dissociation constant of acetic acid is given. It is 1.8 into 10 to the power of minus 5 at 25 degree Celsius. At the same temperature we have to find out the pH of the solution too. So if you simplify this, C into root of Ka upon C is equal to root of Ka into C. That is the value. Now if I substitute all these values, this is equal to root of K value is 1.8 into 10 to the power minus 5 multiplied by concentration of the solution. C is a concentration. It is 0.1 moles per liter. 0.1. Here I will write all the data. K is given. C is equal to 0.1 mole per dm cube. This is a concentration. This is equal to, that is equal to root of 1.8 into 10 to the power of minus 6, that is equal to, if you work out for that, the square root of 1.8, square root of 1.8 is 1.342, 1.342 up to the accuracy of third digit into 10 to the power of root of 10 to the power of minus 6 is 10 to the power of minus 3. So this is the hydrogen ion concentration. Hydrogen ion concentration in the solution. Next, okay, next is pH is equal to minus log of H plus ion concentration minus log of 1.342 10 to the power of minus 3, that is equal to minus of minus 3 log 10, that is 3 minus log of 1.342. This is equal to 3 minus log of 142. First you write a log of 142, that is 3 minus, the characteristic of this is 0.1342 log of 1.342342 is equal to 0.1277 1277, that is equal to 3 minus 0.1277, that is equal to 2.8723 2.8723. This is the pH of the 0.1N acetic acid solution.